All right, welcome everyone. So I'm joining here from Amsterdam. Umang, where are you?
Hello everyone, I'm Umang from Bangalore. Good morning, good evening, and good afternoon to everyone watching.
Outstanding. So we've had a few of these now over the last 3 weeks. We've talked mostly about MCP and how we at DevRev interoperate with Cursor and Claude and Raycast and Warp and many other tools out there. And obviously, folks have found those to be incredibly useful. Now, what I wanted to do was shift gears and start talking about a little bit of how the sausage is made. So behind the scenes, starting to talk about our agent architecture and specifically how we actually evaluate and specifically what metrics we're using to actually evaluate the agents that we're shipping out there. And obviously, there's a lot to say about that. And this will be a multi-parter again. And today's episode is going to focus on a couple of metrics that Umang you've been looking at, right?
Yes, so hello everyone, I'm Umang. I'm part of the engineering team at DevRev and I work primarily on agent and workflows. And I've been working on evaluating agent quality, and seeing how just to make our agents better.
Mm-hmm.
Yeah, so that's what I've been working on. And today we'll be looking at a couple of these metrics, our learnings, and how we have sort of ensured that all the agents that we release are best in class.
Okay, so let's have a look. I know you've been doing some runs lately.
Yeah, so I have my cursor open right now. I was just running this simulation of our CX agent, the one deployed on DevRevs plug widget,
Mm-hmm.
and running it against a couple of test cases because we wanted to try GPT 4.1 mini model. It's pretty fast compared to the other models that are out there. And I was just observing the traces of an LLM. So over here, like what we have is this is a multi-turn scenario. So the agent is agent, but even the user who is testing this agent is also powered via an LLM. So I was just looking at this LLM's thoughts, seeing that, hey, I need to respond as the user to the assistant questions. Following the reference conversation, I'll ask for a concrete example. Then there's like, it's sort of very interesting to look at these traces since the conversation seems to reach a natural conclusion with the ticket being created. I should end the conversation. So it's quite interesting to look at these sessions.
Yeah, absolutely. I'll maybe want to dissect this in a couple of ways. One is that these conversations, to some degree, and I know the value of synthetic data sets and coming up with high quality scenarios is it's very exciting, and a lot of people are working hard on coming up with very authentic synthetic data sets or scenarios to do testing, not only for verifying and evaluation, but also for fine tuning and many other things that we're also doing. But tell me about sort of your synthetic test generation, the data sets that you're producing. Like, what does that look like, and how do you make sure that the quality of the scenarios is very high? How do you make sure there's a good distribution?
Right. So, as you mentioned, it's a very exciting research space as well. And there's a lot of like focus on variability and variance as well as authenticity to real data. And right now, the data set that we see, which is perhaps the most common approach we have, is using actual data from production and using that to generate more test cases. And of course, people can add and in a semi-automated way use LLMs and generate these test cases, have some annotations on top of that. So that's the synthetic data generation part where we use actual data as the seed to generate a bigger data set. And there's of course the other part which I was showing, which is you have these reference trajectories, but when you're actually running an agent against them, especially like with real knowledge bases and tools, the trajectories may differ. And at that point, you also need to bring things to track and adapt as the test cases are running. And that's sort of where these simulated LLMs come into picture.
Yeah, and of course, obviously, you're looking at these scenarios yourself. This is, probably not something you do with all the different scenarios and all the different test runs. But obviously, you've got LLMs as verifiers in the loop. Tell me more about how you've set that up. Like, what are the LLM? What does that logic look like? What is their function, and how well does it work?
Right. So I'll just pull up runs from a different uh, session that I was running a couple of minutes back.
Okay.
We sort of have vibe coded this internal visualization tool to look at all the traces and the metrics and all. And we're working on making this accessible to our customers who are building on top of us.
Sure.
But just let's just look at this. Like this was a session with 44, like a test set with 44 sessions. There were like 270 turns. with 45 different skill calls. And yeah, like there could be multi-turn scenarios, and like there are a couple of
And
metrics, but
just
we are
to just to be clear, so this is completely engineering UI that you whip up just for your own purposes. But when you talk about turns, really what you're talking about is a conversation that's going back and forth between two parties, right? And so if you say multi-turn and you say there's 40 turns, really what you're saying is there's 40 back and forths.
There could be back and forths, and especially like these agents also invoke skill calls and tools. So essentially, like a skill call and tool invocations are also counted as turns, because it's one way to define it. But in this, like there's user messages and those back and forths, and interleaved between those trajectories are tool calls. So
Got it.
that's also right.
Perfect. So basically, human to agent interaction plus whatever interactions the agent is having with subsystems and skills and other things that are happening behind the scenes.
Right, exactly.
Okay.
And we have some rough metrics. This is just an overview, but if we sort of dive into this sessions UI, we can actually look at how the session went. There's like this one had 3 user messages, this one had 10 skill calls, and you can sort by these and just look at these metrics. And we'll dive into these metrics, of course, in a bit. But just to understand how we do it, and once like the simulation runs, just click on one of these. We have this like this is like an entirely simulated run AI assistant and AI user, let's just say. So why isn't needs response toggle triggered? And so there's user messages, there are skill call requests and responses in between. They are also sends thinking messages. Thank you for clarifying, Umang. Let me search for this. So this is sort of the UI we have, and on top of that we have a couple of metrics. Each metric like assigns a score. It could be 0 1, it could be 1 to 5 scale. We'll dive into the specifics of that in a bit. And yeah, these are sort of the metrics we have. And should we dive into one of these?
Well, I mean, I see faithfulness there. It sounds important. Tell me more about that. Is that the same as like groundedness, and does it protect against hallucinations? Is that what I'm reading?
Yes. In fact, faithfulness is also called as groundedness in a lot of contexts, and
Yeah.
it measures hallucinations, which are perhaps the biggest problem with LLM models as of today, where they can make up facts, or a lot of times they make certain assumptions about the situation, which is not present as part of whatever knowledge base or tool calls they have access to. So it's a very important metric, especially because as of today it fails a lot of times. So that's why it's much more important, and it's one of the most important quality measures aside the other metrics that we look at. And coming to like how it's measured, like people intuitively understand faithfulness, but when you have to measure it, you sort of put it into a more structured manner. And there's this very popular library, open source library called Ragas, and we'll just look at its approach to measuring faithfulness and sort of see of how our experiments with this metric went. So the way this metric works is that first of all, it's also an intelligent metric. To measure an intelligent system, you need an intelligent metric, and by that I mean it uses LLM models under the hood to make certain judgments. But it's not like one single huge prompt which is making the judgment. It's sort of broken down into steps, and the steps are like it extracts the truths, and then the claims that are made from that truth, and then it verifies that that these claims are correct, and then computes the score. So like this is the formula where you say that these are the number of claims that were essentially backed and then not. And yeah, this is just like from the Ragas official documentation. So that's the official metric, and perhaps we can also discuss how we experimented with it, and especially how this metric needs to evolve with tool use and more agentic applications.
Yeah.
So one of the things that we saw, in fact, before we dive into that, let me just show you a quick view of this metric in a couple of sessions. So what it looks like how to configure email integration snap in, it receives a faithfulness score of 5. Then you see like this also provides an explanation of why it gave a fine 5. So assistant response closely mirrors the steps. So while measuring, it has access to the response of knowledge search, which it uses to verify that this agent response is actually built on, like, grounded to this context. Uh, so this is the explanation for this particular score. And let's also actually look at one of them with a low score. I'll just sort this. Look at this one. So here, like, why isn't the needs response toggle triggered for customer message posted by email integration bot? So, like, email integration is one of DevRev's biggest offerings in, like, biggest features in the support app. And the users come and ask this question, and, like, we gave a score which is not good. So let's see what explanation it has. So it says that the assistant's response makes plausible and logically consistent statements, but the specific claims about the need response toggle behavior, this are not directly supported by this. And in fact, it also mentions, like, different articles. So there's different questions, but sources claims that needs response is set when customer new message is received. So it's sort of specifics of the exact feature itself. But if you dive into it, it will actually, like, you'll be able to realize that the responses that the agents is giving is sort of making certain assumptions. And this is perhaps the biggest problem with AI agents and LLM models in general today.
Yeah. What's fascinating is, and thanks for showing me sort of both a good and a bad example, just that makes it sort of a little easier to understand. Tell me this, are you using sort of the same kind of models, the same frontier models to do the LLM based verification and the explanation as well? Or how do you think about that?
So on that front, like, it's a trade-off. Like, in general, the more powerful models perform better, especially like in any sort of task. But one thing we have realized is that it's a trade-off between cost and latency versus the performance. And we'll dive into this a little bit later as to what the research is showing us in terms of how we can improve on those fronts. But
Okay.
yeah, like, we can use the smaller and cheaper models, like the mini models or the nano models, run them multiple times, maybe to get better judgments.
Yeah.
So that's, like, usually much cheaper than having, like, because as you saw, for this faithfulness, it needs access to the entire context.
Right.
And these contexts are, like, tens of thousands of token long, like, over a multi-turn conversation.
Right.
So it's not something which you can, like, totally explode, that your evaluation costs are as high as your runtime costs.
For
So
sure.
that's a trade-off that's made.
Yeah,
Uh,
that's. But let me ask a more specific question then. What about just how you're directing the frontier model in this case to actually present a case or present a score around faithfulness? Is there sort of a standard template for how you want to prompt the frontier model, or is this something that we produced in house?
so it's inspired from a lot of, like, online research and a lot of these open source libraries. And that's where we sort of, let's look at what happens here. So under the hood, like, Ragas has a prompt which is based on top of, like, whatever methodology we described. And most of the time, like, this prompt is sort of generic, so it applies to a lot of generic scenarios. But there are other metrics that we'll look at later where this prompt needs a lot of customization because of the type of thing it is doing. And even in case of Ragas, like, this is one of the things that we have, is that uh, especially with tool usage, like, this is our observation, the density of information is much higher. Like, earlier
Yeah.
it used to be, like, retrieved articles, but now it's entire JSON files. And there's, like, this huge, like, LLMs run code, they have these tables with different columns, and the information density is much higher. So the LLM models sometimes, like, need to be, like, this metric when it is being computed. We might also want to do some customization in terms of what actually matters, how to manage those prompts. And that is sort of where we sort of forked Ragas and did our customization, because the biggest problem with Ragas that we saw was there was no visibility into the explanation and hallucination.
Yeah.
Yeah. And this, so actually I have an example for this as well. So this is one of the other things, like, other sessions that we were observing, where are all issues linked to this particular issue resolved. Like, this is from DevRev, we have an issue, and there are, like, other linked issues, style issues, and so on. And here, like this agent called a skill call fetch object context. It received this context, but now this is a JSON. It has like so much information in it. Then so on, and it said yes, all of this is resolved. And if you like actually look at the skill call responses, there will be a stage name completed and so on. However, if you look at the Ragas metrics, like it sort of lost the information and did not surface it to the end user, and it sort of reduces the trust with this metric, because now like it just says it has some consistency, but knowledge may contain unsupported claim. Like
Got
that is not really helping us. So we had to fork it off and sort of surface these explanations, control the prompt a little bit, and that is like a common pattern with a lot of these LLMs judge metrics that we have today.
Yeah, that makes sense. And I can only imagine, I mean, obviously in this particular case, what you're evaluating at the end of the day is a customer experience agent. So it's very specific to, human inquiry, and, there's only so many back and forths that you're going to have with a human. There's only so many skills that you're going to call. When you start to talk about other agents that are going to do increasingly long horizon or longer horizon tasks, let's say 20-minute tasks, 60-minute tasks, so on and so forth, or whatever the equivalent is in terms of machine time, you're going to have many more turns. You're going to have way more complex interactions, and that interaction and those interactions, especially as you start to get to more agent-to-agent language, can be very dense in terms of the amount of tokens that they produce. And so bringing all of that in to the context of creating a faithfulness score, that's obviously going to be very expensive and is going to require a lot of innovation. So I am looking forward to seeing what other things people are going to be talking about when it comes to coming up with better scoring mechanisms, coming up with better strategies. So, but before we get into that topic, maybe we shift over from groundedness and faithfulness to task completion. I saw that as well in your earlier dashboard. Can we talk about that?
Right. So let's talk about task completion. We have that over here. And in general, like, okay, I'll open this one.
Okay.
So let's open task completion. And this particular metric, like people intuitively have a sense, but they don't really have a definition of what matters and what not. It's only when they look at like 50 different sessions and try to pass fail those test cases do they realize this. And we sort of actually, yeah, let's look at a few examples. So here it asks like how to configure email integration snap-in. So it just fetches it from the knowledge base, walk me through a concrete example, and so on. So like it got a score of 1, which is a good thing. And similarly, there can be like bad examples, like how can archive tickets be cloned? And over here we noticed that there are no skill calls. Like this model just rejected, but did not even call any skill. Like it's just probably some bug in the prompt or just how that particular LLM model is behaving. So it received a zero score essentially. So coming to the definition of this metric, it's also like we sort of construct it on top of LLM models, but over here you first extract the questions or the tasks depending on the agent, and then you analyze it in context of this organization, what this agent is supposed to do. You evaluate it using a prompt. And yeah, so coming to this metric, our experiments with this metric, we initially started with deep eval, which is like again one more very popular open source library for metrics. And this is a good starting point. We looked at a few examples, vibe checks looked good, and yeah, but then we ran it over our historical data, and we noticed a lot of false positive, and sort of felt this need to customize this particular setting as well. And the reason I say that, like there were 3 or 4 main things that we felt definitely needed our customization, is that the prompt itself sometimes needs the judging prompt, the verdicts and the scoring, that needs more remarks. Then the agent's role setting also comes into picture. Let's dive into that as well. And of course the custom examples, like any LLM model performance improves drastically if you give it like few short examples. And yeah, the examples have to be in context of that agent. So this is sort of where we landed for our CX agent. Like it's the base prompt is you are an expert evaluator, blah blah blah, evaluation criteria, there's this grading rubric. And even for grading rubric, we're saying that it should be 0 or 1. Just try to keep it very binary. And in some cases, like if you want a score of like more than 2 levels, you can have it. But the general guideline over there is monitor that not all your scoring goes into that middle bucket, because that's what LLMs tend to do. uh, and yeah, this is like the agent environment. Like if we tell it about DevRev before evaluating if it's supposed to work or not. One interesting example that we saw was that people were just typing random things, JJKK, or write me a poem, write me a travel itinerary to Dubai, and so on. And in those cases, we have guardrails in our system to reject those queries. And those like effectively those systems and those conversations were getting zero score, which was obviously not good. So we again had to customize this particular metric, and examples we have already talked about.
Yeah, and I do want to double click into sort of the binary scoring that you talked about, and then you said the reason why this is advisable, and also based on your empirical evidence, it seems like it gives you the best results, is because to some degree you also want to just sort of pass fail some of these scenarios to say, was it complete, was it not complete? One person might say, well, why don't you give me more of a sort of a fractional definition so that I can say it was 90% complete. And what you're saying is that as long as you're using an LLM as part of the judging criteria, it's going to be very difficult because the LLM is going to start to give partial credit to everybody for and that's where it has a difficult time categorizing. Can you explain to me why you think that's the case?
So the biggest reason behind that is that people themselves don't know what those partial scores mean. Like let's say if we talk about a scale of 90%, 80%, like 1 to 10 scale, then in those cases, roughly people know that okay, 7 to 8 is good, 9 10 is excellent, 1 to 3 is bad, but what is 2, what is 3, those kind of things people are not able to put into words. And like we actually did this exercise where we looked at actual conversation, and this is very much important, like for anyone who's building agents and metrics on top of those agents. Please like realize this and take our advice. You have to actually look at conversations and come up with your own framework as to what constitutes a partial score. Even in our case, like we said that partial score is only given if it's like there is a temporary workaround which is available, uh, because like the user is immediately unblocked. But uh, a lot of times people are not able to do that, and the more buckets you have, the difficult it gets to do so. So
Yeah,
that's the main reason why this is suggested.
absolutely. So I mean, creating any kind of gradation is obviously hard, and I think this makes sense. Let's move on. I mean, you've shown me a couple of examples of scores that are primarily being governed by LLMs. So it's a lot of like sort of machine on machine evaluation. Is there any level of sort of human evaluation or human annotation that's going into this evaluation machinery?
Right. So that's the most important part of using these metrics, because like when you're defining these metrics, you need to have confidence on top of them.
Sure.
And the reason you need confidence is that you're running these on thousands and thousands of conversations. You're using this for different things. Like we're using task completion for prompt optimization. We're using task completion for dashboards and reports and so on. So like trust on this metric is very important. And as I said, like we have to manually annotate this data. Right now, I have this Google Sheet from one of the analysis manual annotation exercises that we did a couple of weeks back. Uh, it was a painful experience, so I think we need to build another vibe coded tool to make this easier.
Yeah.
But over here, we actually like sat down in a group for 1 hour and said, what do we score this? And we have like task completion by an AI, by a human. And like we also try to give an explanation of when we are giving it a score of zero point 0.5, this yeah, there are also human explanations for the same. And there are a couple of other metrics that we were trying, and in fact like this is what the end distribution looks like. So there was this metric we were trying to create, which was user satisfaction. uh, and yeah, like as you can see, this is the correlation between manual score and automated score, and there's just like no significant correlation between these.
Yeah.
That sort of led us to realize that okay, we can add this metric, we can add 15 other metrics, but as long as it doesn't align well with the human judgment, we don't use this metric. For task completion also, like this is a slightly older graph, we did make some improvements to it, but over here we see correlation with human values. So that's why like this particular task completion metric we claimed as, okay, this has a good precision when it a precision and recall score essentially with
Mhm.
what it categorizes as good and bad, and that's why we trust these metrics. So this sort of exercise is very much important for anyone out there.
Yeah, and I mean, of course, you're talking about human annotations that are happening in house for us, but obviously, there's companies out there that we don't have to name them, but they this is all they do, right? Is basically make it easy to decentralize and maybe outsource the human labeling aspect. I mean, how do you think this scales as we build more and more agents? Number one, number two, and how do you feel like LLMs start to help us with this as well? And what does that look like? Because obviously you don't want to create a bias, but naturally anything that humans are doing, there's going to be somebody out there that's going to believe that there's an LLM that can do the same thing.
Right. So that's a very interesting space out there. Like, there's actually a paper called "Who Validates the Validators" by folks from UC Berkeley about the same, and it's actually a very interesting space because in the early stages, at least when the metric is being defined, and when you're looking at the first 50 or 70 or 80 conversations, at that time you don't want to bring in much bias because you're still sort of exploring new and new types of questions, new and new types of scenarios, and trying to rank them and score them and so on. But after a while, like it takes cognitive load. Like it takes 30 seconds for someone to even read the response. So any sort of tooling that helps over there will be really valuable, like in saving human time. And after a while, like once this exercise is done, we can involve more LLMs. Like we can say a human is verifying the output instead of writing the whole output and so on. So we have to like figure out as an industry, how do we not just start relying entirely on LLMs without having structures on trusting their values and seeing how they correlate with humans.
Yeah, that makes sense. So you mentioned the Berkeley paper, but I know there's another paper that you were waiting to show me. Do you have that pulled up and we can talk about it?
Yeah, this one was actually GEval. It was by Microsoft Research. And the problem that this was solving is that uh, LLM as judges, like LLMs are probabilistic systems. And when they sample a score, that sampling itself is probabilistic. So in general, like the variance sort of becomes high when you are using this. Like sometimes it gives a 2 or a 3 and so on. So this
Right.
paper actually took a very interesting methodology for tackling that specific problem. Is that instead like in, when the token which is predicting the score, that token is getting uh, predicted, you just don't take the most, like you just don't randomly sample out of all. Instead, like the LLM models, like with open source models, you of course have all the data, but OpenAI and a lot of providers also give you back the distribution, or at least the top log probabilities for the top tokens that were going to be predicted.
Right.
So at that time, like what they do is they sort of take a weighted average over this. So like if this particular example, like it's based on chain of thought, but at the time of sampling, if it was having like score of 1 with 20%, score of 3 with 50%, so it sort of normalizes over all of that and assigns like a weighted score of 2.59. And this sort of helps in reducing that randomness in this entire process of scoring. There's a lot of randomness, but anything that helps in reducing that and making it more trustable is helpful.
Very nice. Anything else in this paper that you wanted to highlight?
Uh, yeah, mainly like this was perhaps the most interesting thing. There are a couple of libraries which are built on top of this. DPVal was one of them, and there's COT, but which this employs. But yeah, there are a lot of these guidelines, general guidelines that are constantly evolving. This paper is also slightly old now, so a lot of research that's happening in this space to make them faster, make them cheaper, and in fact, like make them so fast that you can evaluate them before even sending back the response to users, and just have like these guardrails which are running super fast. So there's research happening there, and of course, this particular paper and its successor are more aligned towards the trust built on top of these metrics.
That makes a lot of sense. Thanks for sharing that. What I'll say is that obviously we talk a lot about safety, speed, and stability, and obviously everything that we've talked about here in terms of collecting metrics and measures and being able to feel like we're making changes responsibly. There's a lot more that goes into it. So hopefully in subsequent conversations we can discuss that. What I find really fascinating is when you talk about getting inspired by RAGAS and DPVal and some of these other methodologies that are out there in the market. And the fact that we've had to fork some of these ideas or maybe do some things because multi-skill agents, which is kind of where we're headed, they require a little bit more thinking. So I'm encouraged that there's going to be maybe some things that we can contribute back to the community as it pertains to evaluations and baselines and generating really, really good results. So that's one thing. But more importantly, I think that it'd be really interesting to see how it all kind of fits into something. Obviously, everything we looked at was sort of in disparate places, whether it was a vibe coded dashboard or this and that. I mean, how do you think about, because we are a horizontal agent generation or building mechanism, right? I mean, like our product actually helps and produces those kinds of outcomes. How do you see it all kind of coming together and streamlining so that we have a better sort of intuitive experience within the application? Do you see some of these metrics just being a part of the agent builder experience so that you can actually just do a one click where you can sandbox things, deploy things, test them, and then make sure that everything looks good?
Yeah, absolutely. That's all part of the experience. We are working on building that and making it available to our customers. All of you who are building agents on DevRev. We have this sneak peek into our dashboard. This is the dashboard, the dashboard for the agent that we were just seeing a couple minutes back, which is our CX agent deployed on Plug. And we have like user satisfaction, we have task completion, and this is like we have deployed it for a lot of months now, and like we can see the deflection rates. There's different ways, different metrics, different ways to measure deflection. A lot of metrics we have already seen, but there's a lot more that is covered in this dashboard, like week performance, monthly performance, and so on. This is like
Okay.
channel wise, Slack, WhatsApp, and like Plug Chat and so on. So yeah, excited to work on this and bring it out to all our customers using DevRev.
And what you're saying is even the evaluation metrics would probably be visible natively inside the application, and people can make it, build some automations on top of that to figure out when to defer and when to deploy and so on and so forth.
Yes, absolutely. Like all of this is powered by DevRev's platform itself, dashboards, objects, custom objects, and the like UI based analytics engine that we have.
Yeah.
So all of these things are like built on top of our platform.
Yeah, and of course there's a lot of products out there, and we might talk about a few of them that are in this space of evaluation and so on. And it'd be great to see how we can partner with some of them, and that way there's just a better sort of interoperation story between us and other tools that are out there in the market.
Right.
I'll stop here. Anything else that you want to bring up, Umang, before we call it a day?
No, that's it from my side.
Okay, sounds good. So I'm looking forward to maybe part 2 of this, where we talk about maybe some other metrics and really focus on other aspects of this space. But for today, thank you so much for everything that you've shown and all the hard work that you're doing. Looking forward to seeing more from you, and folks who have joined us for this live stream, thank you so much, and we'll see you next time. Take care.
Bye.
Bye.